This video provides a description of the functionality and uses of the Aeroflex 3920 digital radio test set input and output connectors. To get the most out of this video, we recommend viewing these videos beforehand. The GEN, TR, and antenna connectors are used to transmit and receive RF signals to and from the 3920. The GEN connector is used to transmit the signal from the 3920 RF signal generator to a device under test. The signal level present at the GEN connector can be adjusted from -130 dBm to as much as +10 dBm. The GEN connector is an output only. Avoid connecting the output of a radio transmitter to the GEN connector, as it is possible to damage this output with a high power signal input. The antenna connector is used to route low-level RF signals of around -10 dBm or less to the 3920 RF receiver. Though it is an RF input, avoid connecting the antenna connector to a radio transmitter, as high-power RF signals applied to this input can damage the 3920 receiver. The TR connector is a bidirectional port. It can transmit and receive signals to and from a device under test. The instrument RF generator signals present at the TR connector can be adjusted from -130 dBm to -30 dBm. The TR connector can safely route RF signals as high as 125 watts to the instrument receiver. When the TR connector is connected to the antenna port of a radio, the 3920 generator can send RF signals to the radio, and the 3920 receiver can receive and analyze the radio's transmitter when the radio is keyed. The instrument can interface with a number of different USB devices. A USB mouse and/or keyboard can be used to control the instrument by simply connecting the device to a USB connector. A USB memory stick can be connected to transfer user setups, screenshots, test results, and other files. In advanced applications, a USB to serial device can be inserted, allowing the instrument to control other serial devices. Two more USB connectors are available on the rear panel. An accessory microphone can be connected to the mic accessory connector to key the generator and to provide voice modulation to the generator. When connected to an external transmitter, the mic accessory connector can be used to key the transmitter either remotely or by using the PTT button. The audio N1 and audio N2 connectors are used to route audio signals to the audio analyzer and the oscilloscope. In a typical application, the TR connector is connected to the radio's antenna input. The modulated RF generator signal is received by the radio. The radio demodulates the RF generator signal and sends the demodulated audio back to the audio in connector. The audio analyzer can then perform a number of measurements, including demod level, receiver synad, distortion, hum and noise, SNR, and squelch level. The function gen demod out connector will either present an audio signal generated by the function generator or the demodulated audio from the receiver, depending on configuration. In a typical application, the TR connector is connected to the radio's antenna input. The instrument's audio generator signal is applied to the microphone input of the radio. When the radio is keyed, its transmitter is modulated by the audio signal applied to its microphone input. The signal transmitted by the radio is demodulated by the instrument's receiver. The 3920 applies the signal demodulated by its receiver to its internal demodulated audio analyzer. The demod analyzer can then perform measurements such as transmitter modulation level, synad, distortion, hum and noise, and SNR. Audio signals applied to the Channel 1 and Channel 2 scope inputs are applied directly to the oscilloscope Channel 1 and Channel 2 scope input selections. The test port can be remotely programmed to control external devices. The digital multimeter, volt ohms, and common connectors apply signals to the DMM for volts DC, volts AC, and resistance measurements. The common and amp connectors apply signals to the DMM for current measurements only. The rear panel connectors consist of the AC mains input, connection to remote interfaces, and external reference functions. The audio in, audio out, client USB, and auxiliary IF connectors are currently not used. They are reserved for future development. The PS2 mouse and keyboard connectors, which were used on earlier 3901 and 3902 models, are not present on the 3920. The 10.7 MHz IF output provides the 3920 10.7 MHz receiver IF signal for advanced signal analysis. The external reference I/O connector, when set as an output, generates a 10 MHz reference frequency that is used to lock external equipment to the same time base as the 3920. When set as an input, the external reference I/O connector will receive the 10 MHz reference frequency generated by external equipment, locking the 3920 to the external equipment's time base. The external trigger input connector is used to supply external triggers to the oscilloscope. The sync I/O connector generates and receives timing pulses for testing Tetra and TEDS type systems. The GPIB IEEE 488 connector is used to interface with GPIB remote control. The Ethernet connector allows the 3920 to be placed on a computer network. 2 USB connectors are supplied on the rear panel. The VGA connector is used to connect to a VGA monitor, which will then echo the 3920 display. The parallel printer output connector is used to interface with parallel printers. The RS-232 serial connector is used only for specific functions in certain systems. AC mains is applied to the AC mains connector. The AC mains switch, when set to on, applies connected AC mains voltage to the 3920 test set.